This is my Python keyword tier list. Now, starting off with true and false. So, true is a Boolean value. Obviously, it's true. Overall, uh, not that useful, but it comes up sometimes. Kind of mid. I'd go same with false as well. Now, none is Python's equivalent of null or undefined. I'd say it gets a little bit more use for me than true or false, but not by much. I think I would put it as B tier though, just because it's a little bit more useful. Since you can detect if things are like unassigned or now is. You can check if two objects' identities are the same. So for instance, checking if something is none, checking if something is false, which you shouldn't do. You should just put not. Checking if something is true, again, just have it on its own. You don't need to check against true. You can check primitives against each other with this, but you shouldn't do that. You should just use equals equals. When you do this with objects, it does not act like equals equals. Because unlike with primitives, when you define an object, it has a different identity to every other object. So this list and this list are not the same. They are equivalent, but they have a different identity. So this is not this. It's pretty based. Again though, I don't get much use out of it. B tier. Now, not just flips the value of something. Now, this is the first time we're getting into something called truthy and falsy. In Python, values can be truthy and values can be falsy. What that means is when you use them in a Boolean expression, they can act as true and act as false instead of having to be converted into a Boolean. So not one is truthy, so it gets converted to false. Not zero is falsy, so it gets converted to true. But normally, you just use not to turn a true into a false or a false into a true. Again, I get some use out of it, but it's not, not that much. And, you gotta have it. And is pretty important. You have Boolean expression and a Boolean expression. Put them together into and. It tells you if both of them are true. It does have another weird use case with truthy and falsy values. If the first value is falsy, you get the first value back if you assign it to something, or else it turns to a second value. I never use that. I just use and as and. And as and is A tier, in my opinion. It's pretty good. Or is a pretty similar case. It's just the or operator. And it has the same sort of weird use case, except now we get the first value if it's truthy instead of if it's falsy. And then the second value if otherwise. I'd also put this one in A tier. You gotta have it, Now, def. This is how you define functions in Python. Pretty simple, but, I gotta say, obviously, it's pretty dang useful. And def, so short, to the point, I love it. It takes 3 presses to say I want the function here. and I really like that. S tier, global. Now, inside of functions, you can access variables that are at the top level, like is true or false or get falsy, that aren't in a function, but you can only read them. You can't write to them. Global lets you write to them in a function. Now, it is considered bad practice to do this because using global is a little slow, but it can have its uses sometimes, especially if you're like not trying to be performant. And really, if you're programming in Python, you 90% of the time shouldn't be worrying about performance anyways. Um, I'd put it B tier, I guess. Non-local does essentially the same thing, but for stuff that's specifically already inside of functions and not at the top level. I think it's a little bit faster than global. I don't exactly recall though, but I don't think it's as useful in the first place. So I put it at C tier. Lambda. Lambda is Python's one-liner function. So you define a function really quickly like that without having to, make this whole structure. It's just short to the point. It's useful when you want a new function like inside of a function call or something, and it's like simple, so you don't want to go and make a whole new function just for that. So you put it in there and bam. Also use it a lot in filters. So I'd say A tier. Yeah, being able to define a function anywhere is pretty nice. Class. Classes are, again, really essential, especially for object-oriented languages. I mean, what more is there to say? Classes are obviously S tier. Async lets you define a function that can be run asynchronously from the rest of your program. That's it. So this can be run like alongside stuff that's already running instead of like going line by line by line. But a little nitpick I personally don't like about it, even though I guess it makes sense, is that like every level of function that includes async needs to have an async above it. I I just think it gets a little bit messy when you have it everywhere. Anyways, it is pretty good to be able to have stuff run alongside each other, but I wouldn't say it's essential. Await goes with async. Uh, use it on async function to wait for it to complete. So right here, you call the function, it's happening in the background, and then when you await it, the program stops and waits until this function completes. I'd put it alongside async. I think that makes sense. They go together. Return, gotta have it. You need a result from a function. This lets you return the result. Absolutely essential. S tier. Pass, it just lets you say that nothing is going to happen here for now. So like while you're developing, you can say, okay, I have a function I'm going to implement later, but I don't want to do that right now, so just pass, and then the interpreter won't get mad at you. Simple, clean, not very useful. You probably shouldn't really have it almost ever in a finished work, but I like having it around. B tier. In. Uh, it lets you tell if something is in something else. Pretty simple. So if this list contains hello, it returns true. Otherwise, it returns false. I'd say I I really like this. It's two letters, and you can tell if something is in something else. I love it. 4. Now you use for with the in operator to say every single item that is in something. You want to do something and know what that item is. Pretty simple. I like it. It is, again, a lot shorter to do than many other languages. As you can see here, we are looping through every item in L. So overall, I'd say 4. S tier. Fight me. Coldest take of all time. Okay. Yield is pretty cool, in my opinion. So it makes a iterator, so you can iterate through a list, for example, but there's a lot more uses, and it's pretty versatile, in my opinion, and they're super memory efficient. Yield is S tier. Import. Again, import, gotta have it. You have a module, you import the module, you use a function from the module, gotta have it. Um, S tier, I guess. I mean, there's nothing really special about it. You just kind of need it. I don't know. I just don't feel like the flavor for import that def, class, return for, and yield have, you know? What is just as important. Now, from can be used to grab a specific thing from a module. So it actually imports the entire module, and then you take something from it, and now you have access to just this. And you can use yield from to yield from every item in a list in one line. Overall, I don't really like selecting certain things from modules. I kind of just like either having the whole thing or having just a wildcard import, but it is nice in some cases. Um, that's a B tier. While, again, something you gotta have. I think it's kind of bland, but you know, you really gotta have it. I'd say same deal as import. Try stops an error from halting the program. Pretty simple. Um, I guess C tier. Now, except always goes with try. Um, you get an error if you don't have except with a try, and except just catches the error, so you can do stuff with it. And you gotta have it, but you know, nothing special. Finally, it lets you do stuff whether or not it errored, which honestly I don't find particularly helpful, because I mean, you can just do that, in my opinion. But I guess it could be useful to some people sometimes, but honestly, D tier. Kind of sucks. With, I think with is pretty special. With is a context manager. What that means is, let's say you open a file. If you have it set up like this, as soon as it exits this block, it automatically closes the file. You don't have to explicitly do that, which is really nice. I like how simple it is, and yeah, there's nothing more to say about it really. It's really simple, but I really like it. I'd say maybe A tier. For as, so as is an alias keyword. So basically, if you're importing something, you can rename it to something else, and then you can use that name instead of having to use the original name. When you use a context manager, you use it to define what variable your thing is in the context. And in a try except, you use it to define an error that you catch and get the variable of the error. I mean, you gotta have it. I like it. Match, it's pretty nice, I guess, when you have a medium number of states that something could be in that you need to go through, and they all have different things need done to them. Other languages might call this a switch statement. I like it, but I don't really think it's particularly useful, and also to get to any logic, you need to go 2 lines deep instead of just one with like a function, which I really don't like. So B tier, I guess. Case, same deal pretty much. To define a default, you use an underscore, and then it lets you do stuff from there. I'll put that right with match. Breaks from a loop. Pretty simple. It's in a lot of languages. And put it at A tier, because sometimes you don't know when you want to break from a loop at like the start of a loop, and the inverse applies for continue. Sometimes you don't know if you want to continue to the next iteration or if you want to break. I like continue A tier. If, I mean, it's another gotta have it, you know, absolute classic. 2 characters, really quick and simple to use. I'd say S tier. Well, I think I'll bump it down to A tier because of performance reasons. For complicated reasons, conditionals can increase the amount of time that logic takes. Same with elif. I like that I don't have to type else if. It's just elif. I really like that. You know what? Because of that, I think I'm gonna put elif in S tier, because I can't recall off the top of my head any other language that has that. I feel like I have worked in one that has that other than Python, but I feel like it's rare. I could be making that up, but I really like that it's just 4 characters. Else, I mean, you know, gotta have it, goes with if. It does have quite a few uses in Python, really more than it should, in my opinion. You do have the ternary, which I really like Python's ternary, because it makes a lot more sense than a lot of other languages. Return the first value if conditional is true, else return the second value. Super simple, I love it. Now, when you're looping through something, like in a for loop or a while loop, if the loop exits without a break, an else will allow you to run more code. I really think this is a confusing use case, and I don't think it's that useful. I've never personally used it. And you also have the try except case. So an else runs if there was no error. But again, why not just put it in the try section? I'm sure there's use cases, but you know, all of this, I think, is just pretty unnecessary for 99% of cases. Um, but this is really good. I love this. For that reason, I'm putting it in S tier. I guess since if is part of that, I'll raise it to S tier as well. Raise is an exception. Simple. Um, kind of boring, but you sort of need it. I'd say C tier. Del, it just deletes a variable. Now look, I think it could be useful. It really could. Like for memory management, I guess, but and not much beyond that, but I'm sure there are a couple uses beyond that. I've used it myself a couple times, but honestly, again, really not that useful. And if you're doing stuff like memory management or performance stuff in Python, I mean, like, you normally wouldn't even be needing to do memory management or performance stuff in Python anyways, so I think I'd put Del in F tier. Assert, I've actually never used assert, but it just errors if a condition is false. It would be useful for like bug testing and stuff. Um, Normally I just use print statements, but in a production environment, I'm sure you'd want to have a debug suite that has a lot of asserting statements in it. So I think it could be pretty useful in that case. So I'll put it at B tier. Now, lazy. Lazy doesn't exist yet, but it is a Python 3.15 PEP. It is PEP 810, and it adds explicit lazy imports. What that means is that when you import something, it doesn't actually import it until you use it, which I think is pretty special. I mean, I think you could do this beforehand manually, but making it an automatic process with lazy, I really like that. I'm pretty excited for it to come to 3.15. I think I will have good use for it. Like I said, if you're in Python, you probably don't need to be doing memory management or performance management anyways, because it's not really like a final product sort of place. But for instance, I have a big utils file for my personal stuff, and you would never do that in a production environment. But if you were doing personal stuff and you want to have a function, but you realize you've already defined a function for doing that in your big ol' utils file, you just grab it from there, simple. But then you have a file that's collecting like 15 imports, and you usually don't need all that. So having lazy imports would be very useful to a lot of production Python code, as the statistics that they ran have shown, but also pretty useful to just hobbyists. I really like the idea of lazy. Um, I think lazy is an S tier, honestly. And yeah, that's it. Let me zoom out a little so you can see the whole thing. There you go. There's my tier list of the Python keywords. Right? That's it. See ya.